For centuries, Betelgeuse was one of the brightest stars in the night sky. Then, it suddenly began to fade. Night after night, astronomers watched one of the most famous stars in the universe grow darker. Some believed they were witnessing the beginning of a supernova. The truth turned out to be even more extraordinary. Every winter, millions of people unknowingly looked directly at one of the most extraordinary stars in the universe. High above the horizon, the constellation Orion dominates the night sky. 3 bright stars form Orion's famous belt. But one star stands apart. A deep crimson light marks the hunter's shoulder. That star is Betelgeuse. For thousands of years, civilizations around the world have watched it. Ancient Egyptian astronomers recorded its position. Greek storytellers placed it on the shoulder of Orion. Arab astronomers gave it the name we still use today, derived from the Arabic phrase often translated as the hand of the giant. For most of human history, Betelgeuse was simply another bright star. Beautiful, reliable, unchanging. But modern astronomy would reveal something astonishing. Betelgeuse wasn't just another star. It was a red supergiant, one of the largest and most powerful stars ever observed. Located roughly 550 light-years from Earth, Betelgeuse is so enormous that if it replaced our Sun, its outer atmosphere would extend far beyond the orbit of Mars. Mercury would vanish. Venus would disappear. Earth would be consumed long before completing a single orbit. Even Mars would exist inside the star itself. It is almost impossible to imagine such an object. And yet, this giant hangs quietly above us almost every winter night. For decades, astronomers studied Betelgeuse because they knew it was nearing the end of its life. One day, it would explode as a supernova. The only question was, when? Stars like Betelgeuse do not live peaceful lives. Unlike our Sun, which has remained relatively stable for billions of years, red supergiants exist in a constant state of change. Deep inside Betelgeuse, nuclear fusion creates enormous amounts of energy. That energy pushes outward. Gravity pulls inward. The balance between these forces keeps the star alive. But in a star this massive, the balance is never perfect. The entire surface constantly moves. Enormous bubbles of hot gas, each larger than Earth's orbit, rise from the interior before collapsing again. Powerful convection currents churn the star like a cosmic ocean. Violent stellar winds continuously blow material into space. Its brightness naturally rises and falls over time. Astronomers had known about these gentle variations for centuries. Nothing about them seemed alarming. In fact, Betelgeuse had become one of the most carefully monitored stars in the sky. It was famous precisely because it was unpredictable. Yet despite all its strange behavior, nothing prepared astronomers for what would happen next. Late in 2019, professional observatories began reporting something unusual. Betelgeuse was becoming dimmer. At first, no one panicked. Variable stars change brightness all the time. That was normal. But the fading continued. Night after night, week after week, the star kept losing light. By early 2020, its brightness had fallen by roughly 2/3 compared with its usual appearance. This was unlike anything astronomers had recorded in modern history. Around the world, telescopes immediately turned toward Orion. Professional observatories joined forces. Amateur astronomers compared their own observations. News headlines spread rapidly. Had Betelgeuse finally reached the end of its life? Were humans about to witness the explosion of a nearby supernova? For a brief moment, it seemed possible. No one had ever watched a famous red supergiant behave quite like this. The mystery had begun. As Betelgeuse continued to fade, the astronomical community became increasingly uneasy. this was not an ordinary fluctuation. For generations, astronomers had studied the star's natural rhythm. They knew it brightened. They knew it dimmed. But nothing in the historical record matched what they were now witnessing. By February 2020, Betelgeuse had lost nearly 70% of its visible brightness. Even casual skywatchers could see the difference. The bright red beacon that had dominated Orion's shoulder suddenly looked weak, almost fragile. Around the world, a single question echoed through observatories, universities, and newsrooms. Was Betelgeuse about to explode? The idea spread quickly. After all, Betelgeuse is a red supergiant nearing the end of its life. One day it will collapse under its own gravity and explode as a Type II supernova. When that happens, it will briefly outshine almost every star in the night sky. Some newspapers declared that humanity might witness the event within days. Social media amplified the speculation. Videos, articles, and headlines claimed the countdown had already begun. But astronomers remained cautious. A supernova was certainly possible. Someday. The real question was whether the Great Dimming was actually the final warning, or something entirely different. To solve the mystery, astronomers looked beyond visible light. They turned to space telescopes, spectroscopy, and years of archived observations. The breakthrough came when researchers carefully examined data collected before the Great Dimming began. Months earlier, Betelgeuse had done something extraordinary. It released an enormous amount of material from its surface. Not a typical stellar wind, not an ordinary pulse, but what scientists now describe as a surface mass ejection. Imagine a solar flare, but on a scale almost impossible to comprehend. An immense plume of scorching plasma erupted from the star. The cloud expanded outward at incredible speed. As it moved away from Betelgeuse, it began to cool. Atoms combined. Tiny solid particles started to form. Those particles became cosmic dust, and that dust drifted directly between Betelgeuse and Earth. The star itself had not suddenly switched off. Its own light had been hidden behind a cloud that it had created. For the first time, astronomers were watching a red supergiant produce an enormous dust cloud almost in real time. The answer did not come from a single telescope. It emerged from years of collaboration. The Hubble Space Telescope had captured ultraviolet observations revealing unusual activity on Betelgeuse before the dimming. The Very Large Telescope in Chile produced detailed images showing that one side of the star had become significantly darker than the other. Together, the evidence painted a remarkable picture. A violent surface eruption had blasted hot material into space. As the gas cooled, it condensed into dust. That dust temporarily blocked part of the star's light from reaching Earth. The Great Dimming was not the beginning of a supernova. It was something humanity had never clearly witnessed before. A giant star creating its own temporary veil. The discovery transformed Betelgeuse from an astronomical curiosity into a natural laboratory. Scientists suddenly had a rare opportunity to observe how massive stars lose material shortly before the final stages of their evolution. Instead of marking the star's death, the Great Dimming opened an entirely new chapter in our understanding of stellar physics. The Great Dimming was solved, but it left behind an even bigger question. If Betelgeuse wasn't exploding in 2020, then when will it? The honest answer is surprisingly simple. No one knows. Astronomers are certain about one thing. Betelgeuse will eventually die in a spectacular Type II supernova. Its core will collapse in a fraction of a second. A powerful shock wave will race outward. The star's outer layers will be blasted into space. For a brief period, it could outshine nearly every object in the night sky. But predicting exactly when that moment will arrive is one of astronomy's greatest challenges. To human beings, 100,000 years sounds unimaginably far away. To a star that has lived for millions of years, it is the final heartbeat before the end. Current research suggests Betelgeuse may still have tens of thousands, perhaps even around 100,000 years remaining before it reaches that final collapse. That means the spectacular explosion is not expected in our lifetime, or our children's, or even many generations beyond us. The universe moves according to a timescale far different from our own. Imagine looking toward Orion one winter evening and seeing a brilliant new light where Betelgeuse once glowed. No telescope would be needed. The explosion would be visible across the entire planet. For weeks, perhaps even months, the supernova could rival the brightness of the full moon. Some estimates suggest it might even be visible during daylight. Night skies would change dramatically. Orion would never look the same again. But despite its incredible brightness, Earth would remain safe. Betelgeuse is approximately 550 light-years away. That distance is enormous, far beyond the range where dangerous radiation from the explosion could seriously threaten life on our planet. Instead of disaster, humanity would witness one of the greatest astronomical events in recorded history. Every major observatory would turn toward Orion. Space telescopes would record every stage of the explosion. Scientists would gain an unprecedented opportunity to study how massive stars end their lives and enrich the galaxy with the elements needed to create future stars, planets, and perhaps even life itself. When Betelgeuse suddenly faded, many believed they were witnessing the final moments of a dying star. Instead, they witnessed something far rarer. For the first time, astronomers observed a red supergiant eject an enormous amount of material that cooled into a dust cloud, temporarily hiding the star from view. The great dimming reminded us that even the brightest stars still have secrets. Every unexpected observation forces scientists to question old assumptions. Every mystery solved opens the door to new questions. How often do surface mass ejections occur on red supergiants? Do other massive stars experience similar events? Could these eruptions influence when and how a supernova eventually happens? Betelgeuse has become more than a famous star. It has become one of the most valuable laboratories for understanding the final stages of stellar evolution. And thanks to new observatories such as the James Webb Space Telescope, future observations may reveal even more about the complex lives of giant stars. The mystery may be solved, but the exploration has only begun.